Pydantic AI extends agent behavior through capabilities, a composable mechanism where a subclass of abstract capability bundles tools, lifecycle hooks, instructions, and model settings into a single unit passed via the capabilities parameter. The following code demonstrates registering a custom capability with agent from spec and AgentSpec, showing how a data class subclass like RateLimit declares its own configuration field. You will see a data class defining RPM as a configurable field, how AgentSpec accepts a dictionary representation of that capability, and the role of custom capability types in bridging the serialization gap between a Python class and the declarative spec format. From data classes, import data class. From typing, import any. From Pydantic AI, import agent, AgentSpec. From Pydantic AI, capabilities, import AbstractCapability. At data class, class RateLimit AbstractCapability any. A limits requests per minute. RPM, int equals 60. Hash in YAML, RateLimit RPM 30. Hash in Python. Agent equals agent from spec. AgentSpec model equals test. Capabilities equals RateLimit. RPM 30. Custom capability types equals RateLimit. Custom capability registration via spec. The RateLimit data class subclasses AbstractCapability with an RPM field, making it usable in declarative agent specs. The custom capability types parameter on agent from spec tells the framework how to deserialize the capability from its dictionary representation. This is the spec serializable path for custom capabilities. Instead of instantiating in code only, you declare the capability in AgentSpec and let from spec reconstruct it. For capabilities with non-serializable constructors, you override from spec to inject those values. The default from spec just passes the dict fields to the constructor, so a plain data class works out of the box. Trade-off: spec first gives you declarative config and easy reloading, but you lose the ability to pass callables or runtime state directly. Non-serializable arguments require a from spec override, which splits construction paths between spec and code usage. Let's break it down line by line. From data classes, import data class. Imports the data class decorator for defining classes that auto-generate init, repr, and similar dunder methods from annotated fields. From typing, import any. Imports any for unconstrained type annotations. From Pydantic AI, import agent, AgentSpec. Imports agent and AgentSpec from Pydantic AI, providing the core agent class and its declarative specification model for constructing agents from YAML JSON configs. From Pydantic AI, capabilities, import AbstractCapability. Imports AbstractCapability, the base class for defining custom agent capabilities in Pydantic AI. At data class, class RateLimit AbstractCapability any. A limits requests per minute. Defines RateLimit as a data class subclassing AbstractCapability, tagged with a docstring describing its purpose as limiting requests per minute. RPM, int equals 60. Defines an integer variable named RPM with a value of 60. Hash in YAML, RateLimit RPM 30. Hash in Python. Agent equals agent from spec. Invokes the agent class method from spec to construct an agent instance, assigning the result to the variable agent. The call is incomplete here. Arguments follow on subsequent lines. AgentSpec model equals test, capabilities equals RateLimit. RPM 30. Constructs an AgentSpec declaring a test model, with a rate limit capability capped at 30 requests per minute. Custom capability, types equals rate limit. Passes the rate limit class as a custom capability type to the agent, registering it as a capability the agent can use. The pattern is spec-first registration of custom capabilities. Rate limit subclasses AbstractCapability with an RPM field gets declared inside an AgentSpec as a dict, and then agent from spec reconstructs it by passing the dict field straight to the constructor, which works because it's a plain data class. The custom capability type's parameter is the bridge that tells the framework how to deserialize that capability. The trade-off is real. You get declarative config and easy reloading, but you can't pass callables or runtime state directly, and anything non-serializable forces you to override from spec, splitting your construction paths. Everything ties together: the capability definition, the spec format, and the deserialization hook, because they're all part of the same composable capability mechanism.
The rate limit capability counts every RPM per minute, yet the minute guards nothing the spec requires.